this. Okay, yay! Okay, hold this up. I'm going to light this. Okay, heat gently, gently. Shake and heat, yeah. Okay, wait. Okay. Okay, heat gently. What do you see? Show the camera what? It turns from blue to? White. Okay. So it turns from blue to white, right? Can you see? Turns from blue to white. Okay. Okay, we can see that. Huh? We can see that. Yeah. Okay. Now, heat another part. Heat another part. Yeah. It is strongly. It is strongly. Of course, it turns to white first. Okay. It turns to white first before it turns to, it is strongly. Yeah. Yeah, that's right. Take away the, careful, you don't need your hand, okay? Yeah, good. That's to take away the water. Remember, don't touch the test tube in any way. Okay, now heat one part strongly. Yeah, heat this part strongly. When you heat it strongly means that you, okay, never mind. You heat strongly means you use the tip of the blue portion. Okay, you use the tip of the blue. So now you heat it strongly. Never mind, no need to shake. Heat it strongly. Okay, the tip of the blue portion. Okay. Now what color does it change into? What color? Black. Huh? It changed into black, right? Huh? Black, huh? Okay, now we heat it strongly. Heat it strongly. Another part. Yeah, heat it strongly. Yeah. Okay, very strongly and longer. Yeah, very strongly and longer. Very strongly and longer. Let's see. Yeah. Okay. Just hit one side. Hit this side. Hit this side. So that we can see the black as well as the, finally, the what? Brown. Yeah, we're going to get brown soon.
It's brown already.
It's brown already, yeah, okay. Let it cool. Let it cool.
It kind of looks like black.
Huh?
The brown looks like black.
The brown looks like black. No lah, brown is brown lah, no. Huh? Brown is brown. Can you see? Black is like that. Brown is like that. Okay. Actually, the black has turned brown. Oh, the black has turned brown. Now, what is actually happening is this one is slowly decomposing. Okay. Now, if we bring your book, you see where you are. We bring your book here. Then we do. We bring your book. This one camchai already. Okay, I'm going to tell you the. I'm going to tell you what is actually happening. The copper 2 sulfate blue crystal has what we call water of crystallization. This is called the water of crystallization. Okay? So this is CuSO4.5H2O. water of crystallization. So this is water of crystallization. So when saturated copper sulfate crystallizes, it incorporates every unit of CuSO4 incorporated 5 molecules of water. That's why this appears blue. So when you heat slowly and gently, which is not easy to do, you get copper sulfate only. Now this is white. So you get white like that. You drive the water of crystallization away. Okay? You drive it away. And when you drive it away, you can see the water condensing on the top part of the test tube, right? Which we must prevent the water from coming back into the hot test tube. Otherwise you will crack the test tube. Okay? So now, this is minus 5H2O. Okay? And then when you heat this, it goes to black. And you know what? The black is copper 2 oxide. This is black. Copper 2 oxide. This is black. And this is minus SO3. Sulfur trioxide. There's some sulfur dioxide. So sulfur tri means 3, right? Huh? Trioxide gas. Sulfur trioxide gas. And this is an acidic gas, right? Huh? Acidic gas. And we saw last week that it turns green UI, yellowish or red. Orangey or reddish. Yeah? Okay. Then you heat some more. And you know what? Voila! You heat some more. Minus O2 coming out. Very difficult to test this one. But when O2 comes out, you get copper, which is brown. Yay! That's exactly what happens. Like that. Okay, from blue to white to black to brown. Huh? Yeah. So this is a chemical change. Okay, this is a chemical change. Do you think all of them are chemical changes? In a way it is. In a way it is. Because it breaks up into simpler substances. But what is actually happening is we can actually change the white to blue quite easily. We can change this way quite easily by adding water. So we can change white to blue very easily. And the white one, we call it white anhydrous. Anhydrous copper 2 sulfate. And this blue is called hydrated copper 2 sulfate, because it is hydrated because water can be added back like that. Okay, so anhydrous, white anhydrous copper 2 sulfate can become blue copper 2 sulfate hydrated, and this we have it in our book. Yeah. We have it in our book here. Can you see? Yeah? Can you see the book here? Huh? The white anhydrous copper 2 sulfate here, gotten from here. You heat, you can get this here. And then you get white anhydrous copper 2 sulfate. And then you add water, that the blue appears back. But you know what? If you add alcohol, pure alcohol without water, then you will not get blue. You will get a wet patch or wetted patch here. Can you see? And that we want to do today. Let's see how we can do it today by adding a liquid which is not water. Now, how to get a liquid which is not water? So we will use some porcelain here. Okay. Right. We take some blue copper 2 sulfate. Okay, we take some blue copper 2 sulfate and we heat it so that it becomes only white. Now that takes special skill to heat it so that it becomes only white. Let's see, let me do it. Let me do it. Let's heat and stir, heat and stir, heat and stir, heat and stir. Is it becoming white now?
A bit.
Yeah. Maybe we put it higher up, then you can see. We put it higher up. Yeah, okay. So is it becoming white? Almost, huh? Wow, not really. Hey, don't fall out, don't fall out. Don't fall out. It's becoming white, right, huh? Or whitish. It's becoming whitish. Can you see? Okay. So this is whitish and it's losing its blue color slowly now. Not easy to get it white without it changing to black. Okay. So we have to heat it gently. Let's see whether we can get it all white. That will be some achievement. Okay. Some achievement. That's one way of heating it gently. Instead of shaking the whole test tube, we stir the anhydrous blue, the hydrated blue copper sulfate. Come on, turn white. Wow, this one is hot now. Is it turning white? Yeah? It is, right?
It's a bit of black.
It's a bit of black. We don't want the black, we want only the white. Oh, we want only the white. Okay, we try to get, we heat the metal spoon. We heat the metal spoon and then you will drive away the water of crystallization. The metal spoon, the copper 2 sulfate adhere to the metal spoon and it turns black. Oh, difficult to get it white, right? Unlike our book. By the way, the book is written by truly yours as well as Dr. Yap Ban Ha. Dr. Ban Ha is now holds a PhD in maths in Singapore. Can you see it's almost white now? Let's try to heat it almost to white. You think we can almost go to white? Wow, okay, this is almost white, right? I don't want you to change to black, that's why. Not so easy, We took a long time to heat gently also. Okay, we can take this to be white. Okay, we take this to be almost white. Not rather white, but almost white. Okay. Okay, this is almost white. Okay, that's fine. This is almost white. Now, what we will do is we are going to add 2 drops of liquid. 1 drop is water, the other drop is pure alcohol. And let's see what happens if we drop. Be careful, this is hot. We drop 2 drops. 1 water and 1 pure alcohol. Where's our pure alcohol? Where's our pure alcohol? This is not pure. In a moment, I'll be back. Okay, this is pure alcohol. I hope this is pure. Okay, so what we are going to do is we are going to put a little bit of water here on your left to the camera, right? And it turns really blue, right? Can you see? It turns back to blue. But if we were to add pure alcohol, I hope this is pure, then the color will remain white. The color will remain white. Can you see? Can you see it remains white or almost white? It doesn't turn blue like this. You see? So it remains white. Can you see? Yeah. So this tells us of something like that. This tells us of something like that. Of course, if we can get it all white like this, it will be good. So when I wrote this book, we were able to get it completely white like that. And therefore, white anhydrous copper 2 sulfate can be used as a test. For water, it will turn blue, but if it is not water, it is an organic liquid like pure alcohol, it will not turn blue. It will just be wet like that. And this is the best picture that we ever had. Yay! And this is the book, Qualitative Analysis, but unfortunately, Marshall Cavendish is not going to promote this book. But I'm going to promote it here on YouTube. and is meant for all chemistry students all the year up to year 10. Year 10 is Sec 4 in the British system, or in Malaysia they call it Form 5. Okay, it's pre-junior college, qualitative analysis. And of course this is a fantastic metal displacement which we'll do some other time, where these are pure silver. Yay! Thank you.